Okay guys, here we go with the first video for chapter 18. So we're going to be talking about confidence intervals for proportions. We will eventually take to confidence intervals for means. I think that comes in chapter 21 or 22. I think 22. Okay, so I want you guys to get the idea that you do have somewhat of a background for this. We'll get more detailed with it, we'll get in more depth with it, but you do have kind of a general idea of what a confidence interval is, okay? Or should I say what it shows. So if I wanted to say what is the average length a battery will last in a new model of a laptop, okay? So let's say to find this, I took a simple random sample of 50 laptops. Okay. I'm going to give myself a sample mean of 32 hours. Okay, and I'll give myself a standard deviation of 1.08 hours. Okay. I'll tell you it's approximately normal, but we also know due to central limit theorem that it would be approximately normal, so you have 50 laptops, that's a large enough sample. So if it follows a normal distribution, I could get some idea of what's going on with my data. So here's my mean at 32, 1 standard deviation away, 2 standard deviations away, other direction. So what we know about a normal distribution is that 95% of the data lies within 2 standard deviations of your mean. Okay? So it is a safe assumption for us to say that about 95% of data will lie somewhere here. So what we have is kind of this interval or range from 29.84 to 34.16, where we believe that 95% will lie somewhere between here. Okay, so it's a reasonable range. For our data. Okay, so we're fairly confident, in fact, we're 95% confident that our actual mean, our true population mean, will lie somewhere between 29.84 hours and the 34.16 hours. So this is very close to what our confidence interval is, okay? Well, it will be slightly different for a 95% confident interval, but the way that we can understand it is very similar to this. So the idea that we are 95% confident that this range is a plausible range of values where we feel our true population mean, the amount of hours that these batteries last for, will lie somewhere between these 2 values. So how I got this, guys, was I took my statistic, my X bar. I took my statistic, X bar, and I added and I subtracted 2 standard deviations away from it, because I understand 2 standard deviations away from the mean is about 95% of my data. So this is what we're going to be doing to find our confidence intervals. We're going to be taking our statistic and we're going to be adding and subtracting a certain range of error or margin of error to it, okay? Our margin of error is not usually going to be as easy as just 2 standard deviations away, but it will include the idea of a standard deviation, and this will work around your confidence interval, or your confidence level, I should say. Okay, so the idea of a confidence interval would be that the sampling distribution of a statistic tells us how close to the population the sample mean is likely to be. Statistical estimation turns that information around to say how close to the statistic
the unknown population is likely to be. The confidence level describes the uncertainty associated with the sampling method. So this is the idea that, there is an uncertainty here, that we're pretty confident that we know where the true population will be, but it doesn't mean that it has to be there. It could sometimes be outside of our intervals. So it is also describing, or it does describe the uncertainty along with it. So an interval estimate is defined by two numbers between which a population parameter is said to lie. So for example, A comma B is an interval estimate that states the population mean is somewhere between A and B. Interval estimates would include the true population parameter, but some would not. So I think this last one is really important for us. Okay, so how we would find an interval, and this I kind of showed you on that quick example, or that quick setup. A C% confidence interval gives an interval of plausible values for a parameter. The interval is calculated from the data, has the form. So here's your statistics. So it's either going to be X bar, that's your sample mean, or we're going to be starting with our sample proportions. Okay? And to that, you're going to add and subtract a certain margin of error. Now, we did 2 standard deviations, okay? Now, this is always going to change. We're always going to be talking about a standard deviation, but it's going to be a little bit different than what we've seen. We'll call it something different, but we'll see that in video 2. And this 2 is always going to change according to your C% confidence interval, okay? And for a 95% confidence interval, 2 is an estimate. It's not the best estimate that we'll have, though. So we'll see how we'll get a better estimate for it. Okay, so a little bit more background. The confidence interval does not tell us chance. Confidence intervals is not probability, okay? So it is not it's not saying 95% of the time, okay? It's measuring how confident you are that a certain population would lie between a certain range. So it gives us plausible values for your parameter, that's your population. Okay, we interpret confidence intervals as follows. So we are C%, that's going to change. 95% is what the battery one was. Confident that the interval from here to there captures the true parameter of the population and context. These are going to change according to what the problem is. Are you finding a mean? Are you finding the proportion? Okay, and then of U.S. adults, maybe. The battery life. Okay, so one quick example, and then we will move on to video 2. So the Pew Internet and American Life Project asked a random sample of 2,253 U.S. adults, do you ever use Twitter or another service to share updates about yourself or to see updates about others? Of the sample, 19% said yes. According to Pew, the resulting 95% confidence interval is 0.167 to 0.213. Interpret the confidence interval. So we would like to say that we are 95% confident that the interval from 0.167 to 0.213 captures the true proportion of all U.S. adults who use Twitter or another service for updates. That's it for video 1.